Okay. Uh, how's it going? I'm Carl, Carl Jensen. If you, no problem. Okay. So I haven't lectured for you yet. This is going to be obviously my first time with you, and I'm pretty excited. This is a topic that I really enjoy teaching about because I think it's really important to the whole curriculum. What we're learning today is going to set up a foundation for understanding sort of how we communicate data on the web. And so if we get this right, then things like whether or not we use JavaScript and Express or Ruby on Rails or some Python with its frameworks, underline all that is this technology I'm going to talk to you about today. So if we understand this, then those things that are built on top become easier to understand as well. Does that kind of make sense? So it's a lot of pressure on me too because it is that important to learn this. But we're going to take it slow, and over this week is when we're really going to become familiar with this, and hopefully by the time we hit those midterm projects, that's when you're going to lock in a lot of this understanding. So we've got a couple weeks to learn this stuff. But the introduction today, we're going to get prepared to start our first project, which is a really quick project. It's called a project probably because it started out as a project where you would submit it and people would evaluate it. But then we started to think, it's pretty small. We're not getting a ton of value out of that, so let's just make it happen over one day rather than two. So it's called a project. It's a quick sort of assignment where we get familiar with making requests over HTTP, and we're going to interact with the GitHub avatar or API, the GitHub API. So this is what it's all about today: is how do we use this communication method to make requests to a server to ask for information, certain types of information we're interested in, and then how do we actually do something with that information after we've grabbed it from that server. So I'll be with you this morning and then also this afternoon, and the examples will get a little bit more and more complex, but please let me know if I'm going too fast for you. I do like feedback. You can give me feedback on Slack or give it to Davey. He can give it to me anonymously. It's up to you. But I do like to kind of know how things are going from your point of view. Okay. So this is the objective, and this everything we talk about today is going to be moving towards this objective. So Node.js, that's going to be the runtime we're in. We're going to write JavaScript, and we're going to write it in this Node environment. And we're going to make HTTP requests to a server called github.com. It's a bit more exciting and interesting than it sounds, I think. But first we need to learn a few things about how we actually do this. And so we got to talk about protocols. This is something I think maybe there's been some reading on this. We read a little bit about protocols, okay? So here's a definition that I found that I want to share with you. So there are rules involved. We have to make sure that we follow these rules, that both sides of the communication understands what these rules are. In the case of HTTP, it's a formatting of the messages. If we follow the formatting of the messages, then both sides can read and write these messages. The exchange of data. That's normally when we make a request to a website, we are making an HTTP request to get the HTML that represents the page that we want to see, and that HTML is sent to our browser. Our browser then takes that HTML and renders out in the nice kind of interactive GUI way that we like to see it, but what's happening is it's just sending text across HTTP. So those devices, it could be anything. It could be your phone, it could be at a server in Amazon's web data warehouse, whatever it is. Could be this computer, could be your fridge. There's lots of different options nowadays. Lots of things can speak HTTP. So does this definition make sense to everyone? Is that a good way to think about what a protocol is? Okay. So here's a protocol we'll use as an example. So HTTP, the Hypertext Transfer Protocol, right? The KKJP, what's that? The knock knock joke protocol? Is that? Okay, sorry. I got this from someone who taught here. I thought it was actually a pretty good analogy because in order to tell a knock knock joke, all the people involved have to understand the rules that dictate that it is a knock knock joke, right? So let's go through those quickly, right? So starts off by someone says knock knock. That starts the communication. Now both sides are aware that this is a knock knock joke that's going to be told. The other person's responsibility, they're supposed to say who's there, right? So someone says knock knock, the response that's expected is who's there. Now they've established that communication, right? HTTP is very similar in this way, is that we have to send a message in a certain format to get the data that we want back, right? So then we can get a little more dynamic. The person telling the joke gets to now insert something that becomes part of the punchline later on. So here they're going to say orange. And then it's the responsibility of the other side to say whatever they said back to them and then who afterwards, right? So talking about a knock-knock joke like this is kind of boring, but this is how we have to talk about protocols because the rules govern the exchange of the data. Okay. So orange shoe, now we're ready for the punchline. Orange, you going to let me in? That's one of them, right? It could be lettuce who, let us in, it's cold out here, stupid things like that. But I hope we kind of see the point is that if we just say knock knock and they say what's up, it's like, does that really constitute a knock knock joke? Is the person going to be thrown off? Will they not know what to say next as a result of that? And if that's the case, then we've broken those rules, so we cannot have that entire exchange. Okay. Yeah, he's sad because it's a bad joke, that thing's sad because it's a bad joke. All right. So here's some common protocols. We've all interacted with protocols if you've used the web. So FTP stands for the File Transfer Protocol. This is sort of anyone who did any sort of web development or anything like that early on would have used a file transfer protocol client to send files to a server. If not, no big deal. That's what I used to do. POP3, Post Office Protocol 3, version 3. So this is actually an early email receiving protocol. So you'd send a message to the server. It says, give me my email, and the server would then send you the email back. Obviously, it's more complicated than that, but the protocol sort of drives that exchange of information. IMAP is what we'd be using today, because IMAP actually syncs the mail. POP3, when I download it, usually it just deletes it off the server. You could leave it up there or you could delete it, but it's not necessarily syncing those things. Whereas IMAP adds the ability to sync, so you'd think that the protocol might change as well, because the types of things you do, rather than get email, it'd be more like check to see which email I don't have yet maybe, and then send me the things that I don't have and do a syncing process instead. So a different protocol for a different purpose, but with email still. SMTP is the Simple Mail Transfer Protocol. This is the way that we send mail to people. So everyone who sends an email, it gets sent out using this protocol, right? So we have these common protocols. We have to learn. If we want to write software that uses these protocols, we have to go and learn these protocols. And that HTTP is no different. And the nice thing is HTTP is, I don't want to say easy, but compared to some of these, it could be seen as a bit easier. And also the things that we're going to teach, we're not going to get into the depths of HTTP because there's a large specification and it gets quite boring. We're going to teach you what you need to know in order to make requests to a server, get information back, maybe post information to a server, change the information on a server, delete things that are on a server. That's all stuff we want to do with HTTP and pretty much what you do when you're interacting with the web today. So we're going to learn a minimum amount of HTTP today. It follows the request response model. This is a simple model where we establish a connection to a server. We send it a message, and in this case it could be something like get /, and then it's telling it the version of the protocol we're using as well, because that might be important. And then the server says, okay, well, you want to get the root page. Maybe that's just the lighthouselabs.ca homepage. Let me just grab the HTML for that and send that back to you in the response. And I'll also give you a little bit more information. It says that the request, everything went fine. 200 means okay. Everything's good. We don't need to learn the details of the status codes today, so let's not, or at least in order to sort of get the high-level stuff here. But just say that the server always tells us how things went. What did it find the thing it was looking for successfully? No, it didn't. 404 not found, right? That's where that comes from. 400 bad request. 500 server error. There's just these numbers and then these reasons that the server will send back so that maybe the client can do something good for the user to make everything okay still, right? So handling errors is a part of software development, and this is how errors could get sent back on HTTP. So we make a request, we get a response. Then the communication is done, and if we want to get more information, we connect again, we make another request, and we get another response back. HTTP is stateless. It doesn't not know if I make 2 requests in a row. It does not know that it was me making those 2 requests rather than 2 individuals elsewhere. It could be anyone. So that's what stateless means, is it doesn't keep track of who you are between requests. Okay. So here's the client, and we're going to focus on the client today. I'm going to be doing live coding where we make a request to a server, download some information, and then do some stuff with it. So that's what we're focusing on. This is what an HTTP request looks like. And I've highlighted this with these exclamation marks because I really want to bring to light that we need to understand what a method is for an HTTP request and what the path means, or what sort of values we can put in for that. The other stuff is important, but I'd say that the newest stuff and the stuff that's going to make it easier to debug these things is understanding the method and the path. So let's focus on that. But just keep in mind that every HTTP request has 3 parts. The 3 parts are the request line. The request line actually looks a lot like get/HTTP 1.1. So that's how we start off the HTTP request. Within the request line, we have the method and the path. So what's my method on this request? Get. Get is the method, right? So the method is get. I have other options, but for now, get is going to ask the server for information. And the second thing I have here is the path. And so I'm saying I want the root, the information for the root of this website. So / just is the root, but it could be /about or /contact or /schedule. Any of those things could be paths. And the server would then know that I'm asking for the page about, the about page, or the contact form page, or the page with the schedule on it. The path allows us to be a bit more specific in kind of any way that we want. We get to set that up. So method and path, that's the important thing. If we can see how that fits into our request, then we can see how we want to, or sort of what we want to do and what we want to do it to. The third thing is the version here. I'm just going to leave that. If it says HTTP 1.1, good. HTTP 2 is right around the corner. I mean, it's starting to gain a lot more popularity. These things are going to change as we further our careers, right? So don't really worry too much about that version number. But if it says HTTP 1.1 on the request and the response, then that's probably what we'd expect to see today. Then after the request line, there are 2 other parts to a request, an HTTP request. The headers, that's gonna provide meta information about the request. So things that I want to tell the server about this request could include maybe what type of data it expects to get back. So is it HTML, or is it a picture, or is it JSON? You can specify that in a header. What else? Let's see. Well, let's not worry too much about the headers. I'm going to show you examples of those. That's probably when it's going to become a bit more clear. Then the last part, the third part of an HTTP request, is the body of the request. And so if it has the request line, the headers, and the body is going to be the contents that we want to send to the server. And with a GET request, when we're just asking for the root of lighthouselabs.ca, we don't need to put anything on the body. But maybe we're trying to do a login and we need to send an email and a password to a server. Well, we would maybe put that on the body of the request. So in some cases, the body does have a pretty important role. For a GET request, it might not, but it's still a possibility. So every HTTP request has will have a request line. Most likely it'll have headers, and possibly it will have a body. Okay. The methods, let's talk about this quickly. So these methods, the first 2 we're going to learn about are get and post. And I want to talk about the terms safe and safety. Okay. So a GET request is marked as safe. The idea is that when I make a request with the method get, the server will not change its behavior in any way after that. Okay. So what does that mean? I have a website that I show all my blog posts on, let's say. So I write a blog post, I click publish, and now next time someone goes to that site, they see that new blog post. When I get the /blog or /posts request, or I do the request /blog, it sends back a list of those blog posts, and if I make that request again, I get the list of the blog posts again, and if I make that same request, I get that exact same list. So every time I make that request, I'm the same behavior from the server, right? But what happens when I add a new blog post? If I add a new blog post, I'm going to actually use a post request. So instead of a get, I'm going to use a post, and I'm going to post a blog entry. Now, the next GET request that I do, different behavior. I get a new blog post in that list now. So what I would say is that the post request that added that new blog post into my database or whatever it was is an unsafe request because it changed the behavior of the server. Before I created that blog entry, that entry wasn't there. Now that I created it, it is there. The server is behaving differently. I get a different list back based on this request that was made. Do we have questions about safety? I want to make sure it's clear for people because it is the first thing that I use to figure out which type of method or which method I want for my request. I have to make these decisions when I'm asking the server for things. I tell it, and I decide which method to use based on the behavior that I want. So if I'm making a request that's always safe, that doesn't change the behavior of the server, then I'll use a GET request for that. But if I'm modifying the server in some way, for example, adding a new blog post, then I will add I will use a post request because it is an unsafe operation. It's okay? We can go on from that. Okay. So first thing I think about is safety. Is this method safe or not? And the only real safe one is, or the safe one that we're going to teach you is the GET request. The other thing is, do I need to pass body data? And now, HTTP isn't perfect because it's kind of like the law interpretable by people, right? And arguable by people. So a GET request, I've never had the need to put a body on a GET request, although I think it is possible. I'm pretty sure it's possible to do that. But for the most part, you don't do that. So when we actually need to pass body data, it's usually when we're adding data to the server, maybe that new blog post, maybe we're logging in. In that case, we want to have body data in our request. So I'd say if we're passing body data, chances are we're changing the server, so it's unsafe. So in that case, we would use a post request. So there's two types of requests that you could make at this point. One to retrieve information from a server, and one to set information on a server. Okay. That covers most of what we need to do with web applications. There are two other ones that I'm also going to teach you, although I think there are 10 or 12 total. I've never even counted. We don't need to learn these today, but I would say, or even necessarily by the end of the week, we're not using them necessarily. Your assignments won't use these methods, but I want to show them to you because I think for your midterm project, it would be very good to use these methods because these would be more common. It's an effort to make things less complicated, so we'll teach it over time. So put and delete have other purposes. I can use post for either of these instead of either of these, and that's what you're going to do during your assignment. You're going to use post to change the data that's on the server, and you're going to use post to delete things that are on the server. Because both of those operations are unsafe, therefore we should use post for that, right? But if you do want to challenge yourself, if you want to, and I think there's even a stretch assignment for this week to use these, then when I want to modify a resource, if I want to edit that blog post, I would most likely do a put request, and that would actually replace an existing resource with a new resource. That resource is my blog posts, so I just take the one that existed already and right over top of it. That's what a put request is there for. A delete will allow me to remove that blog post entry. these terms and HTTP comes from a time when we were, or not me, I wasn't born, and definitely none of you either. But this was all about sharing scientific documents. So what would happen is you've got these people across the world, and they want to share this information, and so they got these documents, and they want to be able to make these documents accessible to other people. Well, I can get to the document from the server. I can post the document to the server. I can put the document that actually replaces it if it's there already, or it adds it if it isn't there already. I can delete the document from the server. That's what all this is for. And we've just sort of built on top of this and thought about how those files are no longer really files anymore. They're more like entries in a database. That would be more common today. Instead of posting a new file or uploading a new file, we would just be changing or adding new information to a database. But they still kind of fall in line with the actions that we would take on pretty much anything that we need to read, create, edit, and delete. All right. I went a long time on this because it's the most kind of important and kind of new stuff, I think. So the quick thing about path, paths, this exists before Windows. Windows didn't have any, and Microsoft didn't have any say in how pathing would be done on the web. It was all Unix and Unix back then. So we're using Unix style pathing. That means forward slashes instead of backslashes, or backslashes instead of forward slashes. I don't know which way, what you call what, but just follow the diagrams, right? So it would be forward slash forward slash forward slash. That's what I call them, at least. Yeah. Makes sense? You can kind of put whatever you want here. But we will talk over time about convention and sort of common practice with this. But for now, your paths should be pretty straightforward for this week. Okay, so forward slash is the root path. Just keep that in mind. Usually the home page or whatever would be found at the root path. All right, so this HTTP request, I've got my request line at the top, get / so I've told the server what I'm interested in. And I've also got a header here. The header is saying that the host is example.com, and this is a key value pair. What other key value pairs have we used so far? How have we used key value pairs? Objects, yeah. So with objects so far, you've taken an object, you add a key, and then a value for that. So you have some way to label some data, and then the data itself. Well, here that's what headers are as well. It's a slightly different syntax, right? Formatting. So here we would just say the header name, colon, space, and then the value of that header. Okay. Okay. So we also got the server to think about. It's on the other side of our communication. So here's what a response might look like. It also has not a request line, because it's not making a request. It has a status line. So the response has a status line that it responds with, and that's where that number 200, 201, 404, 400, whatever, that's where it would show that status code, and then also the response text, the text that actually describes sort of what we want what that means. So OK just means everything's good. 201 created, we'd get that back if we created a new resource, maybe uploaded a new file or whatever. 404 not found if it didn't find the thing we were looking for. And then it also has the ability to set some headers on the response, so it can tell us information about this response. In this case, the header is content type. So it's saying that content type is of value text HTML. Could be text plain, could be application JSON, could be image PNG. There's lots of options for this. It's really just trying to describe to the browser or to the client. We're not always going to be in a browser. It could be pretty much anything. Any HTTP client could make this request. But the response is going to come back and tell us sort of roughly information about what it's giving us back as data. Here's some common status codes, some I've mentioned already. You don't need to remember these because you could always just search HTTP status codes. You go to the Wikipedia site. Wikipedia has this list for you. You look it up, and the most common ones are just going to become known to you through practice. This is the kind of thing you just look it up when you need to know it. Whereas I'd say you need to really nail the methods and know what they're there for and which one to use in which case. Whereas the status code, it's easy to look that up when necessary. Cool? So just trying to let you know where to use most of the memory bank, I guess. So definitely more on this tomorrow. You'll be doing learn more about web servers, how to implement web servers, how to build a web server in Node that accepts requests and sends responses back. And that's what all of this week is going to be about, so starting tomorrow. Do you have any questions before I start coding stuff? Okay. Let's bring this up. All right. So I've got this page here, or this website, nobelprize.org, and I'm going to go to it. And if I make the request to my browser, I get back this list of data. It's hard to read here, right? But this is we'll call JSON. Has anyone not heard of JSON? It's okay. Okay, so JavaScript object notation. It's a way for us to describe JavaScript objects as plain text, because we can't send JavaScript objects over HTTP. What format does HTTP support? What's the only data format that HTTP allows us to send? Text, strings. Yeah, text, strings, characters. So what we need to do is take that JavaScript object, put it into like this notation here that allows us to describe the thing, so that when we send it across as plain text, we can then read this again, convert it back into JavaScript objects, and use it that way. So it's sort of this interchange format between the server and the client, because our communication does not allow for the communication of the objects that we really want to be sending. This is going to be a problem, I think, because this is going to be really hot still. But I just need something to drink here. So I'm going to bring up the inspector. This is always a good thing to have. And the inspector, when I make this request and I go to the network panel over here, it's showing me the request that was made to nobelprize.org/v1/prize.json. And if I click on this, it's going to tell me more details on the right side. For example, which headers existed on the request and which headers existed on the response. So I can see that my request headers, the headers that were sent when I made this request, look like this here. Here's the request line. Here are my key value pairs. Each one of these key value pairs is something that I wanted to tell the server, or that my browser wanted to tell the server when I made the request. For example, here's the user agent. What does user agent mean? Operating system. Usually not the operating system directly, but I mean, technically the operating system could be a user agent. This is usually, yeah. The browser, yeah, it's another user agent, right? It's something that's doing the requests on your behalf. So I can, in the browser, this is the most common agent. If my operating system was making requests to an HTTP server, then it would be another user agent, maybe called macOS 10.6 or whatever, right? But maybe it's this other program called Postman here that I load up. This is another user agent. It's something making HTTP requests on my behalf, or on the user's behalf. So in this case, the browser is telling the server, I am of this type. I am Mozilla 5.0, Apple WebKit, I am Chrome, I am Safari. Like, why would this browser is obviously Chrome. Why is it telling servers that it's Safari? It's kind of weird, right? It can be whatever it wants, though. Like the user agent can define it as whatever it wants. It sends to the server. Now the server might do things based on that user agent, and maybe that's why Chrome says I'm everything, so that you can't exclude me, right? If I tell you that I'm Chrome, then you might look at me and say, "Oh, you're Chrome. I'm not going to send." You know, maybe I go to the Apple website and they're like, "Well, you can't watch this webcast in your browser. You have to watch it in Safari." How does it know that I'm not Safari, right? Well, it doesn't look at user agent anymore. It probably did before, and then Google got smart. You know, all that type of stuff. Point is, we want to send information on the request that's not really, this is not body data. This is about the request. It's not the actual request itself, right? So that's what the headers are for. It's the metadata about the request. We're even telling the server what type of data we like back as a priority. Like, this is what we like. We like text HTML. That's what we accept, right? So the headers can be used for that. Now, when the response comes back, there are also headers on the response. So for example, content type application JSON. Yeah, that describes this content. The body is just text. But the content type that the header tells us about is actually, oh no, this is some JSON. So you could safely parse this and convert it into JSON objects. That's what we expect you to be able to do, right? What else? Oh, it tells us a little bit about the server. I don't know if I like giving that information away on my servers, but that's up to, up to them here. That's not me. That's the server that's saying it is an Apache server, powered by PHP 5.3.3. Like, it just tells us this stuff if we want, right? Powered by Express if we were doing it this week in Node. Here's a preview. This is a little bit nicer, right? It knows that this is JSON, that the text, that the string represents JavaScript's objects and arrays. So here, why not just, the browser can just kind of show that to me as an array of objects, which is actually pretty nice. The inspector is good at this, at showing us more detailed information about the data that's coming through, and in the format that we like to see. This is an object that has a key called prizes, and that prizes key is an array of objects. Each object represents a year and a category, and the winners of that, potentially more than one winner, an array of winners, laureates, they call them here. With the year, so this data, we're going to go through and we're going to do a GET request to pull this data from a server, and then we're going to go and filter out only the prizes that we're interested in, and we're going to format a list that shows us who won it, what year it was, and who won it. I mean, it's hard to come up with interesting things to do for this day, right? I'm doing my best. Right. Here's that response, plain text. This is exactly what we're seeing here. So get used to using this inspector with the network tab as you're making these requests, as you're debugging your HTTP. This is where I do it. Yeah. Okay. So it's 9:38. Yeah. So here's what's going to happen. We're going to make a request to this. We're going to check to see what the status code is. If the status code isn't 200, we're going to assume that that is an error. We're not going to go into too much depth on that, but we're not going to continue if the status code is not 200. Then we're going to download. This is actually going to download all the data. I'll go through this a little bit more in detail as we go through. It's going to download all the data. Once we have the data, we're going to filter out only those that have a certain type of prize. We only care about maybe the peace prize in this situation. And then we're going to print out for each of those prizes which year and who won it. So we'll come back to this. We'll run this. We'll inspect it a little bit. We'll delete it, and then we'll rewrite it. And that'll be, yeah, the remainder of the morning. Sound good? So let's take a break. And then any questions? Okay. Come back and take a after 5-10 minutes. Let's go again. Let's keep going, I guess. So one thing I forgot that I wanted to show you quickly before we do the coding is just some examples of sort of what these HTTP messages really look like. And the best way to see this is through curl. And I know curl's not super exciting. CURL is a tool that allows us to make HTTP requests. It's another user agent. If I use a -v, it's going to be verbose mode. It's going to tell me a lot more about the request that I'm making. And so this is a good way to investigate what's going on, where I say I'm gonna curl with verbose mode example.com. So I'm going to make a GET request to example.com, the host, and I'm going to ask for the / path. That is just implied. I don't have to put it there. And so this is what it looks like. I made the request here, and it says I'm connecting to this IP address here. That's just, it does a lookup. It says example.com has this address. We get back the IP address. We make the connection connected to on port 80. You see that happening here. So now it is connected to the server. Once it makes the connection to the server in plain text, it sends the following message. Those little arrows at the beginning there, that's just a way that curl is showing us that this is the request that's being made. And the request, it has a request line, right? I want to get the root path. Then it has the headers. And then there's this empty line at the end, and that's how it's saying there's no body on this request. The response comes back, and the response has the status line. The response has the headers here. And then after the headers, there's another new line here saying, okay, well, the headers are done. So the remainder of this happens to be the body of the response, which is actually just all the HTML that the browser ends up rendering, right? So that's what it actually looks like. The browser, when it receives this, it's just this chunk of text. And then it parses that text, interprets it, and then renders it, the HTML, as actual elements on the page, okay? And you can use curl for making any request on here. You can see exactly what it looks like, and it shouldn't be any real difference for the types of things that we're seeing in here. Okay. All right. I've got this code here. Let's go through it quickly, and then we'll delete it and rewrite it ourselves. Okay. So the very first line, I'm using require. The word require, where does this come from? Require. What's that for? Modules, yeah. It's a way for me to import modules. And does JavaScript have support built in for modules? No, it doesn't. Well, it didn't for a long time. And so people came up with their own ways to do modules in JavaScript. One of the ways is called CommonJS. This is where require comes from. Modules are not built into JavaScript, or were not built in JavaScript when Node was created. And so Node said, well, we need to do something to be able to import modules. So we'll use this CommonJS syntax and just build it into our runtime. So every single file that we load into Node, when it loads that file, it passes it a function called require. And then so we can require things like HTTP, okay? Why I said it didn't used to is because with ES6, the newer version of ECMAScript, newer version being June 2015 is sort of when it was defined. In that specification, there is a different way to do modules in JavaScript, and it is now supported. But Node is having a hard time because of this legacy stuff in building its support for this newer version of modules. I think eventually we won't have this require stuff anymore. It'll just say import HTTP from HTTP. That's what the newer syntax looks like. But for now, this is just passed in by Node. So we are importing this module, HTTP, and we're assigning whatever this module has within it to the HTTP variable so that we can use it later on. Okay. I'm defining a function here called makeRequest. What am I passing makeRequest? Why do I pass it a callback function?
So that it keeps requesting it if there's still more data.
Okay. So this callback here, so it keeps requesting it. I only need to make the request once here. The reason I need to pass the callback is because this is an asynchronous operation. Right? So how long does it take for an HTTP request to be made? Yeah, there's like no answer to that question, right? Because it just takes as long as it takes. And JavaScript is single-threaded, so it means that we cannot run 2 lines of JavaScript at the same time. We have to run them sort of in sequence all the time. And so the reason why we're using this callback is because when we make the request, we know it's going to take some amount of time, and we're going to give it this callback is going to be, this is the behavior I want you to trigger when the request is complete. So here, when we make the request, we pass the callback in, and later on, once we've downloaded all of the data, then we take that data and we pass it back to whoever made the function call in the first place using the callback, okay? So that's make requests right here. I'm setting a breakpoint. Has anyone not seen these breakpoint things? We haven't really taught them or introduced them. Okay, so I'm going to talk about this quickly. I get to run this program in this editor here. I get to set a breakpoint, and with a breakpoint, it'll stop executing the code on this line. Let me take a look at what's going on, and then I can tell it to go to the next line one at a time, or just continue running the way that it would have otherwise. So this is a debugger. This is a code debugger. When I run this code, just going to close. There we go. So the very first thing that actually happened was, actually, let me set the breakpoint here, because may as well start at the beginning. The first thing that happened is we required this library. The second thing that happened is we defined this function. The third thing that happened is we defined this other function, and then we defined this third function. So we imported an HTTP library, then defined a couple functions, and then we called this print physics winners function. Okay. So I'm going to step into this function. Just using this tool is going to allow me to go into this function and stop on the first line. Here I am on the first line of print physics winners. And I can now see, okay, it's going to call make request. And what does it pass make request? A function, right? This whole thing right here, that's my callback. I make the request, and when the request is complete, call this function, passing in an error if there is one, and then, or data if we were successful. If there was an error, then we'll log out the error. It's basic handling, not very good, but basic. Otherwise, there is no error. So in that case, we're going to call getFilteredWinners, which is a function that takes in, it looks like an array of prizes and a category that we want to filter on. So this is telling me I want to I want to take the list of all the winners, and I want to filter out only those that won physics prizes. Okay. So when I make when I make this function call here, I can step into this function and see what's going to happen. Make request. It's passing in that callback. The callback is of type function, and it takes an error in data, so it knows that this is the function that I pass to it is the one that looks like this. So when I make the request, what I do is I take that HTTP library, the one that I required, and I call a get function on it. Why do we think it's called get? Because safe, yeah. And exactly, it's wrapping up this idea, this concept of the get method, which is safe, into a JavaScript function that we can call in JavaScript. And this is ultimately just going to build out that HTTP request as plain text for us. And it knows that it should put get for the method because we're calling the get function. I could do http.post. Or maybe just http. I don't know if the API supports just request. And then I pass it a big object with all the stuff on it that says the method is get or post or put. And the path is forward slash, here's the path. It's forward slash v1 forward slash prize.json. Right. I also pass it a little bit of information about, it knows what port I want to use, because I'm telling it I'm using just plain HTTP, so it should know, the browser or this library here will automatically use port 80 to make this request. And it'll connect to the host that can be found at nobelprize.org or api.nobelprize.org when it does its lookup for that address. So I've really given it pretty much all. I've been able to create a request out of just this information. Does that make sense? Now, when it's complete, when this request is complete, then it's going to call this function here. So that means that http.get takes two parameters, potentially, right? A string that has the path that I want to make the GET request to, and then a function that I want it to call when it's complete, when it's made that request. And what I get back in that function is the response. So this is going to be just like a raw response object that has all the information that I need to know about the response that was sent by the server. And this is all the Node library, the Node HTTP library, that's doing this for me. It's taking this thing, building the request, making the request, getting the response back, then going through that whole response, building out the response object in JavaScript, and then sending that thing to me when it calls the function I provided to it, right? So I can't just continue here, because if I do, it's just going to call this function and then kind of forget it, right? I need to set another breakpoint here at the beginning of this function. Now, I don't know how long this is going to take. Chances are it's imperceivable in terms of how long it takes. When I hit play, it's going to build that request, send it to the server, get the response back, and then call my callback, okay? There it is. It just called my callback for me because I got the data back. And I look at that response right here, and the response has, well, it's a little bit easier actually. If I take a look at my variables, I've got this response variable, and I apologize because it's so hard with these small screens. But you can see that this response object that's sent back, it's of type incoming message. This is something that came from the Node HTTP library. It defined this for me. And in there are things that it deems important as part of a response, like the headers. Here are the headers for this response, nicely bundled into a JavaScript object for us. Here's the version of HTTP that was used. I could check that out. I could see if I needed to. I've never done it, but possible I could use it. Status code is 200, and the message is OK. So I can say if response.statuscode is 200, everything was fine, and if it's not 200, then I've got a problem. I should check to see what it is and maybe handle that as an error. Maybe it says, oh, if it's 404, I say the resource you're looking for is not found, or something like that. URL, that is actually, that doesn't matter for the response. I'm not sure. So you're just seeing here that this response object has some stuff in it. A lot of stuff we don't care about, and a very little bit of stuff we do care about. So I'm taking that here and I'm saying if the response status code, and I can see right here as I roll over this, because I've stopped execution at this line, I can see exactly what the value is right now. It's 200. So it's not going to hit this condition, right? Instead, it's going to go past this to the next line down here and continue executing. So what I'm doing here is I've made the request, but I haven't actually downloaded the entire body of this response, because how big is the body of a response? It's the same kind of thing like how long does an HTTP request take? It really just depends what's being sent back. If it's an image that's 1.2 megabytes, that's a lot different than 400 characters of text. Those are very different in terms of size and the amount we have to download. So with HTTP, what we'll do is we'll actually download that body in chunks. We'll set up these events that say, when you have new data for me, I'll grab that data, and then when you told me that all of the data is downloaded, I'll take that data and pass it back to my callback, or I'll know that we're done. So that's what's happening here. We create a closure. So this is a variable outside of these functions that stores the current state of the body that we've downloaded, and it starts off as an empty string. Right? We're going to say that this response, we want it to be of UTF-8 encoding. I put that in there because it's good to do. I don't have time to get into encodings and character encodings and all that, but for now, UTF-8 is sort of standard what we'll use. It's not something that uses Cyrillics or something like that. That's why we care about these things. Does it contain characters that are not part of maybe standard English character set? Well, we can totally support those things. We just need to make sure we encode them in the right format. So just encode it as UTF-8 right now. And then these are the two important parts for this exercise. I need to set up an event here. It says, hey, response, when you have new data, call this function for me. I'm interested in any new data that you have, so I'm going to register this function with you. I'm going to say this function needs to get called anytime I have new data. That's what this looks like right here. Response on data. I'm setting up an event handler. When new data is retrieved, it'll call this function passing that chunk of data in. And so what this is going to look like is all right, let's say that this the body of this response is broken up into two chunks. The very first time we would get, and it could stop right there, right? It could stop right there on the G. It doesn't matter. It doesn't care. Takes this. That's my first chunk. We take that chunk and we append it to the body. So now the body contains, that body variable contains all of this text here, right? So then the response says, I have another chunk of data for you. And it looks like this. It starts exactly where we left off. And it goes all the way down. Maybe it stops somewhere. This is just 2 chunks. It could be 50 chunks. Takes this. This comes in as our second chunk. We take that chunk. We add it to the body. We've now taken the first chunk, second chunk. They've both been connected. Now we have the full HTTP request, the body of the request or response, right? Does that make sense? We wouldn't receive any more data events because there's no more data to download after those 2 chunks were fully downloaded. But the library itself, the response knows that it is done. It has hit that end of file or end of line. This thing here, basically whatever signifies that there's no more body data, it hit that. Said, okay, well, if I hit this, I need to now tell whoever's interested that we've also ended the transmission of the data. And so that's what this is here. It's an event that says we're done now. So now we know there is no longer going to be any more data chunks that are being sent to us. So what we should do is just call this callback over here. And here we can see this happening, right? So I start off by setting up that variable. I set my event handlers, and then I just wait. I just receive that first chunk quite quickly. This is what it looks like. And if I go all the way to the bottom, it's not the end of the data. It's just wherever that chunk finished. And if I hit continue, did it? That's not the same end anymore. So that's another chunk of data. And if I hit continue again, and continue, and continue, we can see that body should now contain all of that data that was downloaded. Wow, it's a lot of it. Including, now this looks more like the end, because this is what I'd expect at the end of a bunch of objects and arrays. So I believe that this has now downloaded the entire thing. And since that's the case, it triggered the end event. So now I can send the body, no error, to my callback. Remember, it looks like this. So this is the function that's going to get called now. Here I am. Error. No, it's null. Now it's going to call get filtered when it's yes.
What causes it to go in chunks? Just like the nature of like how the internet uses packets to send data, so like it can't just get it all at once.
Yeah. Yeah. So the question is, just for the video, I guess. Why is the reason why it has chunks? Is it because of the nature of transmission of data over the internet, for example, using packets? Or is that kind of yeah? Yeah. Like I said, we can get files that are larger than the size of normal packets, and so that would be a reason why it would need to be chunked into pieces. Yeah, chances are that data about the response could all come in one packet. That's probably a small enough amount of information. But if it's a 3 megabyte image or a 20 megabyte MP3 or music file or something like that, then we can download all those things, but it's all going to happen in chunks over as packets. Yeah, yeah. And it uses TCP, so they should happen in the right order. And that, yeah, that we should always get them in that order specifically, because at a different layer of the networking stack, it's going to make sure that we fully get that one packet before it receives the next packet before it receives the next packet. Okay. So here we are. We've now successfully asked the server for the data. We've retrieved that. We downloaded it in chunks. We took the whole thing, passed it to this function. Now we're going to call get filtered winners, passing that data in there and saying we only want the physics winners for this one. So I'm going to step into there. Oops. Come on. So now I'm at the top of get filtered winners, and it passed in the data and the filter we're interested in. So we take that data and we call JSON parse. There's sort of two sides to this operation of serialization. JSON parse will allow us to take a string of JSON and convert it into objects and arrays. And JSON stringify would allow us to take an object or arrays or a combination of those things and convert that into a string that we could send. So you got JSON parse, JSON stringify, and it converts back and forth between JavaScript objects and text strings. So what I'm doing here is I'm taking data, and if we take a look here, we can see that data is an object, and the key that I'm interested in is the prizes key. So that's why I'm going to just take that data object, or that JSON, convert it to an object, and then grab the prizes key from it. I've done it as one step here rather than two. If I did this as 2 steps, it might look like so first I parse the data, and then I take the parsed data and I grab the prizes key from it. But I don't necessarily write code like that. I tend to do a bit more. If I can chain like that, it's a little bit easier for me. Fewer variables, so I'm going to just keep it like that. So here we go. Step over, and we see the prizes is now a parsed. It was a parsed JSON. Now it's an array of prizes, and we can see that each year we have a different. Oops. Here we can see the prizes have different categories to them. Okay. So then, well, if that's the case, if this is an array of 589, it looks like, or 590 different elements, prizes, then we want to filter that list out, and we only want to get the ones where the category is equal to physics in this case. So has anyone not seen the array filter function? I can take an array, and then based on a condition, I can only have it return a new array with only values or only items that match that condition in it. Okay. So if I have this array of prizes that have a whole bunch of different categories, then what I expect it to the filter function to return to me is an array that looks very similar, except the only objects that are going to exist anymore are the ones where the category equaled physics. And we can check anything inside there to see, and we can check multiple things where it's this and this, where the category is physics and the year is odd. You could where the year is divisible by 2 perfectly. Like, you do anything you want to do with these filters. The filter function takes in this predicate. It's not a callback because it's actually not an asynchronous operation, but it is the delivery of behavior, right? So I'm saying the behavior, I want you to use this function, and it determines what behavior I'm using to figure out whether or not this item is part of the filter results or not. So here, If this returns true, it's included in the new array. If it returns false, it's not included in the new array. So when the category is equal to physics, it'll return true, which means this object will get included in that new array. And if it returned false, it would get excluded. Does that all make sense? I step over, take a look at filtered. It's a lot smaller now, it's 111. We take a look. Now it's only categories that have physics. So that's what filter did for us, right? Now what I'm doing is my filtered list, I have to go through each of the filtered items, and I have to go to the laureates array, and then pull out just the first name and the surname, and then do that for each winner, and then separate them by commas, right? So I'm doing that in a fancy way here. I'm just going to show you that it kind of works, and then we'll actually write that by hand. It's probably better to do it that way. Oops. All right, so this is what formatted actually looks like. It's the same size array, because I used a map here. Map converts an array of one type to an array of another type. This is going to be an array of prize objects to an array of strings that have the year and the name of the people that won. But we still have the same number. We're still going to have... No, formatted. Sorry, that's the wrong one. This one here. So 2018, Arthur Ashkin, Gerard Moreau, 2017, etc., all the way back 1921, and can keep going. I actually didn't... Yeah, that's cool. Okay. So let's run this quickly. This is what we actually get for the output. Not that anymore. This stuff here. So let's start over and try this again, right? Make sense? What's the first thing that I need to do if I'm going to make an HTTP request? I need to require the library. And this is the first library you're going to use is the request library. The HTTP library. But very shortly today, you're going to go and start using another library called request that's built on top of it, and it makes it a little bit easier. You don't have to do that chunk downloading, for example. This request library takes care of that, and you just say, I want this data, and it does the chunk downloading for you. But you'll see we move from HTTP to the request library. This is abstraction, and we'll do it pretty much every week, right? So I need this library. And if I have this library, then I can do things like get on it. And when I get, I'm going to get the response back. So this is the basic usage of this HTTP library. I've still told it everything I need. I can be explicit about the path if I need to. Otherwise, it's going to assume the route. Let's just console... Let's just look at the response code, or the status code. 200, right? Now, if I put something like that in there, changes it. I'm now getting a 404, because I'm asking for a path that the server knows does not exist. Okay. What I really wanted was this page, though. And if I put this, so I can check the status code, and I get 200 back. If I say present, something like that, run it, I got a 400 back. It's actually kind of weird to me. I expected a 404 because I just expected it not to have that file, but it's saying it's a bad request. So, I mean, I don't know what to tell you, right? Sometimes this happens. I expect one status code, I get another one, but it's their server. They can kind of send me whatever they want back. So, the whole point here is just saying if response.status code is not 200, then we've got some issue, and I don't want to then try and, like, I'm not going to try and parse an empty body. I'm not getting JSON back. I know that. So I shouldn't try and parse it because then I might get a runtime error for that. So that's why I'm putting some of this error handling in here. For now, we'll just console log error, error, or let's say status code is, get out of my way. All right. So now status code is 400. If I go back, fix it, it says it worked. Good. It would get past that. So I've got some basic error handling in here. And now I need to be thinking about how do I actually, now I know that the status code is 200. So that means that I've got body data, most likely. It's never a guarantee. Although, I believe 204 means no content. So if I got a status code back says 204, I'm probably not going to parse that as JSON because it says no content. It should be an empty body. I have seen those for things like delete. When you delete, it doesn't necessarily have anything in the response. So no content might make sense there, right? But all right, I've now got to take this response, and I've not downloaded all of the data. I've only got the actual initial response back. I haven't got all the data packets necessarily, so I need to set up my my events that are going to listen for those things. So first I'll say response on data. Chunk. So when I receive new data, cool. What about like chunk count 0? Now I can't just say, oh, I misspelt it. I know. I'll fix it. That word's really gross to me. This doesn't work, right? The way that I want it to. I wanted this to be at the end, and I wanted to tell me how many times that function got called, right? So that's kind of why we have to have that other event, is I can listen for all these chunks to come in, and they will come in the right order. But if I want to do something once all those chunks have completed, then I can't just write the code down here. This is asynchronous. Whereas this code here, this function, and this will all get run synchronously. I need to set up my second event here. And I don't really know if it gives me data. I don't really care about that. I just care about the context of it being done. All right, so this might work better for me now. Kind of makes sense? Yeah? Cool. Okay. So instead of the count, instead of counting how many times this gets called, we'll just use our, sorry I used let. That's tomorrow afternoon. We'll learn more about that. I'll just put var in here. Var, let, right now, doesn't matter. We'll just, yeah, I think var good. So var body, start as an empty string. And when we receive new data, take that chunk of data and just attach it. Concatenate it onto the end of that string. And then when we're all done, we'll just print out that whole string. Here it is. Right. Okay. So it's not we don't want to just print the string out. We wanted to go maybe filter out stuff, and for just a certain prize, we wanted to what else? We wanted to format the names with commas separating those values, etc. So that's sort of I could put all that logic inside here, inside of this function, right? All that stuff could go right in here. But that's a little bit hard to reason about, right? Like it's hard to it's what if we just had a function that we could pass it data, and then it would then go off and do those things for us. Like that would be, if we broke it up a little bit more, it might be easier. So maybe and I guess here we'll probably want to take in an already converted array, an already parsed array. So let's just say here are the prizes. This is an array of prizes. And I'm going to return a filtered list of prizes. Okay. So this is the function that I want to write. This is what I want it to do. And this is going to be like an array of prize objects, and it will return to me an array of filtered prizes, right? Okay. So here, I'm going to take this body data, var. Let's say so here we go. I'll take that body data, I'm going to parse it. It's converting it from a string into an object. It's that parse data here. And parse data, I could log this out. So when I run this, it's a bit different format. That's because it's actually not printing out a string of JSON anymore. It's printing out whatever JavaScript objects have been converted. So what I really want is up here. It's this prizes object that I really care about. So I should probably be grabbing that instead. It's not going to look much different, except when I go to the top now. Okay, there we go. Now the thing that I printed out is actually just an array of prize objects. So I have this thing that I'm printing out. It becomes quite straightforward just for me to say filter prizes here. Right. And maybe I say the filtered version of those is equal to whatever comes out of this function. So here's filtered. This thing here is going to receive an array of prizes. Have we satisfied that requirement? Yeah. I'm calling filter prizes with an array of prizes. So what this is going to do, I could say var filtered equals empty array, right? And then I could say prizes dot for each, or for var I equals 0, I is less than prizes dot length. There's lots of different ways to do this, right? If filtered, oh no, sorry, if prizes I, what does that represent? First object, then the second object, then the third object. As I increases, we'll go through, index this array. Yeah, exactly. So what this is just the current one that I'm iterating on, right? I'm going to iterate on every single prize. And so the one that I'm currently iterating on, if its category is equal to, we probably should also put a category in here so that, not piece, right? So now I can say I want to filter these prizes based on this category. And so when the category is equal to the category that got passed in here, then we want to take filtered, filtered dot push. Then we'll take that prize and push it onto there, right? Does that make sense? And then return filtered at the end. So if I set, actually I don't need to set a breakpoint, I'll just run it. Now only piece prizes are contained in this resulting set, right? Now, filter prizes, it's kind of like this here. This is does everybody understand how this is working? Yeah. So normally when you see this pattern, what I would tend to do instead is take the prizes, call a filter on it, pass it the function that takes in the item we're currently looking at, which would be the prize in this case, and we say return, well, I guess what you could say is if prize.category is equal to category, return true, else return false, right? This is pretty close in what it's doing, right? It's still checking the same condition. Now, this evaluates to true anyways, right? Or false. So this is a little redundant. Normally what we would do instead is just return the result of this expression here. Does the same thing for us. When the category that we're looking at matches the category we're looking for, then we return true, becomes part of our filter. So I tend to write this function maybe more like this these days. Kind of make roughly, yeah. This stuff, I definitely recommend practicing with it, getting familiar with it. If you see yourself creating an array and then looping through something and then adding stuff under a certain condition, that's a filter. Moving into using this syntax, it's going to be quite a bit faster to write those types of things. And then also, I find this is less error prone when you become more familiar with it. Okay. So here this filter thing is working. We can filter the prizes. Once we filter all the prizes, what we want to do is go through these laureates here, and for each of the items in this array, we want to grab the first name and the surname and make a string out of that. Right? So let's just start off by maybe I just give it an object for one prize, and it returns to me that comma separated list. That could be a nice thing to, like, bit of functionality to do on the side here, right? So I take prize laureates. I don't even know how to spell it. Let's do it this way. Yeah, okay. So the winners, I'll just make it a little bit easier on myself. For me, winners tells me exactly what it is. So I'll just kind of, through this method here, almost like rename this array. Now this array is going to be a list of objects like this, including a first name and a surname. So let's say winners.for each. Let's just first print out what these things look like. And I'm going to have to loop through each of the filtered prizes. And call print winners on that prize here. So we filter out, we only get the piece prizes. We take each of the piece prizes, and for each of those piece prizes, we take that prize and print the winners of that prize. Okay. Well, definitely printing all of them. Let's see if instead of the winner, what we want is the winner.firstname and the winner's surname. And then maybe a comma after it with a space, I think was kind of what we were looking for. looking better. Right. We don't have the year yet, so I'm going to go back quickly here, and I'm going to say this shouldn't actually print the winners. What I'll do is I'll just get the winners. So we'll create an empty string. As we loop through this, instead of console logging this, I'm going to names plus equals this. So this is kind of like I'm just concatenating each name onto here. So this returns the names now. Return the names. So when I get the winners, I pass it a prize object, and it sends me back a string of comma-separated names. I take that here, and I console log it at this point now. And I'm going to say actually prize.year, something like that, maybe. Prize year, colon, space, and then a list of winners. Nope, wrong thing. Okay, so I missed a parentheses there. It's a little better, right? It's close to what we wanted at the end. What's missing? What's wrong with this? Yeah, unnecessary comma. Do we have any solutions for that? Okay, and then for the last thing, yeah, I could also, yeah, I guess, yeah, I could do it for the last item. I think I could also, in here when I'm building the list, I could check to see if it's the last winner or not, and if it is, then don't add it. There's actually something that makes it really easy, and it's the join function. I can take an array of values and I can just join them, and then it knows about the last one and whether or not I should add a comma or not. So let's just switch that over to using that instead, where here I need to take this array of laureates. Do we remember what that looks like? It's an array of objects. Those objects have a first name, a surname, a reason for winning, a bunch of stuff in there. So I want to convert a list of those objects to a list of first and last names. So it starts off looking like this. Oops. Let's make this a bit smaller. And here are the laureates. Okay. All right, so this is what one array of laureates looks like. And I want to convert it from an array of objects to an array that looks more like this. So I want to convert from this into this. In order to convert an array of one type into an array of another type, I like to use a map function for that. Okay. And I could just kind of keep going. I could, the next one here could be Gerard Maru. Is that right? Muru. Yeah. But the point is that I can use a map to iterate through every single item in this array and have it return an array that actually has converted values. Looks like this. Winners.map. And here's the winner. What I return something like this instead. So I grab the winners. Those are just the array of laureates. Look a lot like this. It iterates through each item And for each item, I'm grabbing the first name and the surname. I return that with a space between them, and I get a name like this. And so this now returns an array of winners, first and last names. So the last step is if I join that array of names with a comma, then it'll actually get winners, would return a string now, which is what I expect it to return here. And we fixed that problem, right? It's kind of, yeah, good? Okay. So that was all the requirements. You're going to notice the source code that's in the repo is slightly different. It's kind of where I'd ultimately want to get to. For example, you notice I wrapped this up in another function that takes a callback and all that, right? The notes are here. I will quickly pass out or give you the notes for this afternoon as well. In case anyone gets ahead. And then, yeah, so I'll be back around 3, and we'll talk about more more requests and how to actually do this stuff in Node more. Yeah, we'll do dependent requests. Make one request to get data that we need in order to make the second request. That's something that might be interesting. If that's it, if there are no questions, then I will see everyone in a bit. Cool? All right, thanks.